Dysport is a botulinum toxin product. To understand the mechanism of action of this neuromuscular blocking agent, let's first examine the events that take place at the neuromuscular junction that result in muscle contraction. Activation of motor neurons results in axonal membrane depolarization that is transmitted to the neuromuscular junction. This results in release of acetylcholine into the synaptic cleft. The release of this neurotransmitter involves a complex, multi-step process. Initially, membrane depolarization activates voltage-dependent calcium channels, affecting an influx of calcium into the nerve terminal, which in turn causes synaptic vesicles to fuse with the plasma membrane. Critical to this fusion is the role of the snare proteins which mediate this event. When the synaptic vesicle approaches the plasma membrane, the three snare proteins, SNAP25, synaptobrevin, and syntaxin, interact to form a complex that brings the vesicle membrane into close apposition with the plasma membrane, and subsequent exocytosis of acetylcholine. Acetylcholine then binds to acetylcholine receptors on the plasma membrane of the muscle cell, with subsequent depolarization and muscular contraction. Abobotulinum toxin A is a 150 kilodalton disulfide-linked polypeptide with a light and a heavy chain. The structure of this protein is relatively flat, with three functional modules. The first module is the binding domain, comprised of the C-terminal half of the heavy chain. The second module is the translocation domain, comprised of the N-terminal half of the heavy chain. The third module is a zinc-dependent endopeptidase activity found entirely within the light chain. Following local administration of abobotulinum toxin A, it binds to an unidentified receptor. Abobotulinum toxin A is then internalized by endocytosis. A pH-induced translocation of the light chain occurs across the endosome membrane. This is facilitated by the translocation domain of the heavy chain. Once in the cytosol, the toxin then targets the snare protein. The zinc-dependent proteolytic activity of the light chain cleaves a selective peptide bond within the SNAP25 snare protein. As a result of this, subsequent depolarization of the nerve fails to release acetylcholine due to the prevention of assembly of the fusion complex. This results in temporary muscular paralysis. Functional recovery may initially include sprouting to produce temporary reinnervation, but ultimately the original neuromuscular junction recovers full exocytosis activity.